Hello guys, welcome to my channel. Today in this video I'll be teaching you the converse of theorem 1. As we have proved in previous video that every convergent sequence is bounded. Now we have to show that in this converse we have to show that the opposite of that theorem, which will state that every bounded sequence may not converge. Which means that the converse of theorem 1 is not true. We can say that the converse of theorem 1 is not true. So we have to show that every bounded sequence may not converge. So in order to do this, we have to take an example. Let's consider a sequence Sn, which is minus 1 to the power n. So for this sequence, we'll have alternating minus 1 and 1. If we put 1 here, it will be minus 1. If we put 2 here, it will be plus 1. So we can say that it will give the result minus 1 for odd and plus 1 for even n. So here we will let, if possible, the sequence Sn converges to limit L. So here we will be taking epsilon. We will be taking epsilon equal to 1. So according to the definition, we will have for epsilon equal to 1, which is greater than 0, we will have a positive integer and m such that, since we have two conditions, so first we will take the condition for, first let's consider it for even number, then we'll consider it for odd number. So first Sn minus L will be less than epsilon for n greater or equal to m. So in place of Sn, we will consider it for even number, and epsilon will be taken as 1. So here it will give the result as minus 1. If we put here any m, then we will get even number. So it will be 1 minus L. And for second condition, we'll have to do it for odd number. So for odd, we will consider 2m plus 1 minus L is less than 1. So in case of odd number, we will be getting the sequence as minus 1. So here we will be putting minus 1 L. We can further solve it. Let's take minus common. Then we are left with 1 plus L is less than 1. And according to the property of modulus, we will be getting 1 plus L is equal to 1. We will be using these two properties again. So here, first we will take the left hand side. We will take the left hand side number in such a way such that if we add these two numbers, these two parts, we will get this number itself. So for this, we will be doing 1 minus L plus L plus 1. So in this case, we'll if the both the L will get cancelled out and we are left with 1 plus 1, which is 2. So according to the property of modulus, we can say that this value is less than or equal to this value. So here we are left with these two values. So for these two values, we have 1 minus L will be less than 1. We have to put here less than, which is less than 1 plus L plus 1. L plus 1 is also less than 1. So we are left, eventually we are left with 2 is less than 2, which is not possible. So Sn equal to minus 1 to the power n is bounded, but it is not convergent. So here we can see that the sequence is bounded, since the lower value does not go beyond minus 1 and upper value does not go beyond 1. So it is bounded sequence, but it is not convergent. Thank you.